Okay, for learning assessment 9.12, problem statement is a load requires 60 kilowatts at 0.85 power factor lagging. The 60 hertz line voltage at the load is 220 at an angle of 0 volts RMS. If the transmission line impedance is 0.12 plus J 0.18 ohms, determine the line voltage and power factor at the input. So there's our circuit diagram. On the bottom there, the transmission line impedance is shown. The load. Now here's our circuit diagram again. Now I'm going to label a current IL that we'll be using. So first of all, let's look at calculating the apparent power for the load. And if you'll remember, the apparent power is going to be the real power divided by the power factor. So we have 60 times 10 to the 3 divided by 0.85 gives us 70,588.2 volt amperes. So the load complex power is 7588.2 at an angle of theta. And theta we can calculate from the power factor. It's cosine inverse of 0.85, and it's going to be positive because it's a lagging power factor. If we'd been given a leading power factor, the angle would be negative. So this is 31.79 degrees. So then the complex power for our load is given as follows. And that can also be rewritten in rectangular form. So there's the complex power for our load now. We know for our load that S sub L is going to be VL IL conjugate. So then solving for IL then is SL over VL conjugate. Okay, so then IL is 70,588.2 angle of 31.79 divided by 220 at an angle of 0, and that's going to give us 320.86 at an angle of minus 31.79 degrees amps RMS. Now if we want to calculate the complex power for the line, I'm going to call that the line, then the complex power for the line is the magnitude of IL squared times 0.12 plus J 0.18. So we have 320.86 squared times 0.12 plus J 0.182, which is 12.35 plus J 18.53. And now if we look back at our source, the complex power supplied by the source goes here and here. So S for our source is S line plus S for the load. So S sub S then is 12.35 plus J 18.53 plus 60 plus J 37.19 kVA, which is 72.35 plus J 55.72. And in rectangular form, in polar form, that's 91.32 at an angle of 37.6 degrees kVA. Now, the complex power supplied by the source is Vn IL conjugate. So if we solve this for Vn, we can see it's S sub S divided by IL conjugate. So we have 91.32 times 10 to the third, angle of 37.6 over 320.86 at an angle of minus 31.79 conjugate. So Vn then is 284.6 at an angle of 5.81 degrees volts RMS. And now the power factor to source is just going to be the cosine of the angle on S, which is here, and that's 0.7923, and it's lagging. And the reason I assign lagging to it is the angle on S is positive, which indicates an inductive load, and the power factor for an inductive load is lagging.